So from now on, any kind of question that asks for interval of convergence or radius of convergence, you're going to apply the ratio test. To do the ratio test, first, an is whatever you're adding. Negative 1 to the n minus 1, x minus 3 to the n, and 5 to the n. And because ratio test requires you to take the ratio of an plus 1 over an, you have to find an plus 1. And that means this n has to be replaced by n plus 1. X minus 3. This n has to be replaced by n plus 1. This n has to be replaced by n plus 1. This n also has to be replaced by n plus 1. And plus 1 minus 1 just cancel, so that's why your an plus 1 is. The ratio r is the limit of n going to infinity of an plus 1 over an with the absolute value. And notice that the sole purpose of negative 1 to the nth power just multiplies by negative 1 or positive 1 to the entire thing. And if you take the absolute value, that's meaningless, right? Negative of anything is same thing as the itself if you take the absolute values, right? So we're just going to write this down. Oh, and because we're dividing two fractions, we're going to do keep change flip. So an plus 1 will be just copied down here with the absolute value. But the division will be changed to multiplication. And an has to be flipped. So n times 5 to the n belongs on the top. And x minus 3 to the n belongs on the bottom. And as I said, the negative 1 to any power we don't write because absolute value doesn't care. Okay. Now, we see that it's easier to simplify this divided by this and this divided by that. So let's change places. Limit n going to infinity. X minus 3 to the n plus 1 over x minus 3 to the n times 5 to the n divided by 5 to the n plus 1, and then n over n plus 1. Okay? So I just switched places. So this comes first, this next, and this last. Here, this comes first, and this next, and end last. And the reason I'm doing this is so that I can use the following rule for exponents, right? A to the mth power divided by a to the n is a to the m minus n. You're subtracting the exponents. And this can be applied in these two cases because they both have the same base. 5 and 5, x minus 3, same base. So that allows us to write limit n going to infinity of n plus 1 minus n is x minus 3. It's the first power, right? And what's n minus n plus 1? 5 to the negative 1 power, right? Over n plus 1. And now we can just apply the absolute value individually. So absolute value of x minus 3. Absolute value of 5 to the negative 1 power is same as 1 over 5. So 1 over 5. And then absolute value of n over n plus 1. Can you tell me what the limit of n over n plus 1 is when n goes to infinity? 1. It's 1. And you have 1/5. You have x minus 3. These don't have n, so it's just what it is. Okay, so you end up with x minus 3 times absolute value of 1/5 is just 1/5. And because I need this to be less than 1 to converge under the ratio test, let's figure out what this interval is. And because when it's exactly equal to 1, the ratio test is inconclusive. The boundary values has to be investigated separately because the ratio test doesn't give us a conclusion. So here's how you solve. You multiply by 5 both sides. So this is less than 5. And at this point, you already know that the radius of convergence is 5, right? Because it's in the form of x minus a number, absolute value less than a number. In that case, this number is the radius of convergence. But there are other ways to get it later, so that's just a passing remark. Now, how do you actually solve this? You put plus 5 and negative 5, and this number should be in between, and then you add 3 to all 3 places. And negative 5 plus 3 gives you negative 2. X, 5 plus 3 gives you 8. All right, so that gives you 2 boundary points, x equals to negative 2, and then x equals to 8. Those have to be investigated separately because in that case, the R value becomes exactly 1, and the ratio test doesn't give us any conclusion. All right, so if x is equal to negative 2, you plug it in here, and you get summation n equals to 1 through infinity of negative 1 to the n minus 1, negative 5 to the n power, over n times 5 to the n. Okay? Now, since these two both have powers of n, I can simplify this by saying negative 1 to the n minus 1 over n. You get negative 5 over 5 to the nth power. What's that? Negative 1. Okay. And if this is negative 1, then you have negative 1 to the nth power and negative 1 to the n minus 1 power. They have the same base, so this time they add. The exponents add, right? So you have n equals to 1 through infinity of negative 1. N plus n minus 1 is 2n minus 1 over n. Okay. Can you tell me what negative 1 to the 2n minus 1 power is?
Wait, I have a question.
Yes.
So since we found out that it's converging, do we have to do this part right here also?
Yeah.
Or is this just like...
This has to be done. The endpoint, sometimes the series could still be convergent at these endpoints.
Oh, okay.
It's a must always. Oh, if the question is just about the radius of convergence, then you don't have to do this part because, see, these two further investigation will only let you know whether negative 2 is included or not, whether 8 is included or not.
Okay.
But when you're talking about the radius, length of the radius, that doesn't change whether the endpoint is included because points are 0 length, right? So from here, you can already find the radius because 8 minus negative 2 is 10. 10 divided by 2 is 5. So you get the 5 as the radius of convergence. Yes?
Wouldn't it just be negative 1?
Yeah, so the answer I wanted is that this is just equal to negative 1. Why?
Well, because it's alternating, it's just continually being different.
Yeah, because 2n is always even, right? If you take an even number and you subtract 1, what's that? It's an odd number. And if you have negative 1 to an odd number, it's always negative 1. So this is going to be negative 1 over n, summation n from 1 through infinity. And you can factor the negative out. What do we know about this?
It's divergent.
It's divergent because it's in harmonic series, right? Okay. For the other case, when x is 8, let's take 8 and plug it in here. Let's see what happens. You have summation n from 1 through infinity negative 1 to the n minus 1. 8 minus 3 is 5 to the nth power. N times 5 to the nth power, and then these just cancel. Oh, so it gives you a series very similar to the one we did before. What is this?
It's alternate.
Yeah, it's an alternating series, right? So we check for two things, right? AST. What are the two things we check?
If the limit goes to 0.
If n is sent to infinity,
Can this be conditionally true?
yeah, this is conditionally converted. Yeah. So this will be 0, right? And also an plus 1 absolute value, which is negative 1 to the nth power n plus 1 absolute value, which is just 1 over n plus 1, is indeed, well, that's right here, it's less than 1 over n because n has a smaller denominator, right? If you have a smaller denominator, the fraction is bigger. Yeah? But 1 over n is indeed the absolute value of an. So these two conditionals are met, therefore, converges by alternating series test.
Converges conditionally by
Converges conditionally by alternating series test, okay? And then finally the answer would be interval of convergence is, what's the interval of convergence?
from
Parentheses.
Negative 2 parenthesis,
Yes.
okay?
And then bracket 8.
Yeah, 8 has to be under bracket, okay? And then what's the radius of convergence?
5.
It's 5, okay? Because 8 minus negative 2 divided by 2 is 10 over 2, which is 5. So that's how you're going to end up. Yeah?
The part where you set the limit equal to 0,
Mm-hmm.
if I think through it, I could probably do that.
Oh, okay. You want more details here. Okay.
Just a little
So
bit.
the absolute value will just get rid of negative 1 to any power, right? That doesn't do anything.
Oh, that's
Yeah,
right,
so-
that's right.
So this is limit n going to infinity of just 1 over n.
Yes, okay,
So that's equal to 0.
thank you.